All right, well, in class today, we went over the recursive notes and we looked at 5 different recursive method calls. So let's take a look at all of them here. What makes code recursive? Okay, method calls itself, right? So method calls itself, that's what makes it recursive. So this method's recursive because the name of the method is method1. Right here, it's calling itself. If you look down at my main method, my first call to this particular method, method1, is made with a 3. That 3 is not less than or equal to 0. So it doesn't end up here. It ends up in the else statement. And that's where we see the recursive call being made. Had I gone into the if statement, there is no recursive call. That makes this the base case of the method. It's kind of like a control expression, like a stopping rule. If it's a path that doesn't lead to a recursive call, then that's the way that we'll quit making recursive calls, and that's how we'll avoid an infinite loop. So you might remember previously in Unit 9, if we mistakenly called a method from itself and we didn't like use the word super to steer us to the super class, and we ended up in the same method, it created something like an infinite loop called, a stack overflow. And we've got to watch out for that when we're dealing with recursive code. But this is not going to be a stack overflow because every time I call method1, my x value gets smaller. So even if I started with a really big value of x, eventually it would become less than 0. Starting with the value of 3, the first number I print would be 3, and then I would call the method with a 2. Print a 2, call it with a 1, print a 1, call it with a 0. When I call the method with a 0, I'll end up printing a 0. So we'll see 3, 2, 1, 0 explore here. Now, some strange things can happen though. Like for example, okay, if we just rearrange this and put the print statement on the other side of method x minus 1, this is one of those cases where we're going to sort of disrupt the flow of the program. So if I made this method call, method1, with a 3 right now, okay, the if statement fails. So we don't go into there, we go into the else. But the else code has 2 things that need to happen. Okay, in order, they are you need to call method1 with a 2, and you need to print the current value of x, which is 3. The problem is right here, okay? This is us disrupting the flow of the program. And so now, before you print that 3, you get sidetracked, okay? And this opens up a brand new method call. It's going to look just like this one. It's recursive. It's going to do the same thing. But this recursive call starts with a 2, which doesn't go into the if statement, ends up in the else, tells you to call the method again with a 1 and to print a 2. Remember, the print statement says to print the current value of x. So right here, x has been assigned 2 for this particular method call. So as we work through the body of this method call, unless we see an assignment taking place, which I don't, there's no equal sign other than this Boolean one right here. There's no equal sign, there's no x minus minus, there's no x plus plus. Nothing in this body of code can change the value of x. So when I enter that body, I'm stuck with that assigned value. Okay, so but this print statement hasn't actually happened yet because again, I got disrupted and I went off to some new place. So now what? Well, now I call the method with a 1. Still don't get into that if statement. Call the method again with 1 less than that, which would be 0. Print a 1. But again, that 1 hasn't printed yet. We're still in this, distraction mode. This time, though, when you call method1 with a 0, this is where things start to change because this time you actually go into the else statement. And when you go into you go into the if statement, okay? So now we have a true if. So this time there's only one job to do, and that one job to do is to print the current assigned value of x, which is a 0. Okay, well, after I print that 0, that completes the method1 call. So back here, remember I got disrupted? I now return to that place having completed the method call that disrupted me. and I can continue where I left off, which is actually to print that 1. Once I print the 1, I will have completed this entire method's call, and I would go back to the point where I got disrupted, which was right here. I would check that off. I'd say, okay, I'm done. And then I would complete where I had left off, which would be to print a 2. That would complete method 2's call. This is the stack unwinding itself. And once that was done, we'd come back up here. We'd print the 3. That's the last thing that gets printed. The first was a 0. And that would actually then complete method 1 with the 3's call, which was the original call. But the difference is that we printed in a complete reverse order. Now it's going to go 0, 1, 2, 3 because we changed the order of the events taking place right there. So I got 0, 1, 2, 3 this time. All right, here's another example of a recursive stack, okay? And this one, it's not a void method. We're not waiting on print statements. We're waiting on a return to be made. A method call can only result in one single return. So when you call method 2, if you call with a value greater than or equal to 8, yeah, you just give back 100. It's easy. But what if you called with a value of 5 or 6 or 7, or let's see what we're doing here. We're going to make the first call with a 5, okay? Well, if you called method 2 with a 5, then what would happen is that's not greater than or equal to 8. So it would return 5 plus method 2's call made with a 6. Okay, well, that begs a question. So what's the answer to that? I mean, what is the answer to method 2's call with a 6? I don't know. So I guess I'd have to go figure it out, right? So if you called method 2 with a 6, is that going to the if statement? No, we haven't reached 8 yet. So it goes to the else. It says here, method 2's call, I'll give you a 6 plus I'll give you another call of method 2 that's recursive. This time make it with a 7, 6 plus 1. I don't know what method 2's call is with a 7. So I'd have to run it. I have to go figure it out. Well, method 2's call with a 7 is 7 plus, because again, we're not in the if yet. So it's 7 plus method 2's call made with an 8. Now I know the answer. See, if you asked me what's method 2's call with an 8, I like that question. That's a base case. That's easy. That doesn't open up a recursive process. That doesn't give me any more work to do. If you say, what is method 2's call with an 8? I just raise my hand and say 100. I'm done. Okay. So this right here, now I know that's 100. That means that method 2's call with a 7 is 107. I now know the answer. That means that method 2's call with a 6 is 113. I now know the answer. So what's method 2's call with a 5? It's 118. Now that's not printing a 118. That's the integer 118 being returned. Remember, this is an integer return method. You can give one answer, not 2, not 3. It didn't print all those numbers. Totally different structure than we were looking at in method 1, which was voided and multiple characters were printing. Since I didn't put space characters between them, okay, that's why we didn't see anything like, other than just those values. I mean, if I had put spaces here, now those numbers would have spread out. That's not what we saw though originally, okay? That's why they smushed together. It wasn't like a 4-digit number. This actually is the 3-digit number 118. That's the integer value that got returned. Okay. You could have multiple events like this. So if we look at method 3 being called, okay, let's turn off method 2 for a second. I'm calling method 3 with a 4. It's really no different than what I was just looking for. Here's your base case, right? We're kind of, oops, wrong one. Here's your base case. We're looking for values less than or equal to 1. So if we think of like this original call being made here, which was method 3 called with a 4, the problem with that question is it's got a lot of pieces to it. Since I don't go to the if statement, I have to go to 3 plus method 3 called with a 3, right? 4 minus 1 plus method 3 called with a 2, 4 minus 2. Again, there's no reassignment taking place here on Z. So if you call it with a 4, it's a 4 the whole way through. All right. Well, I don't know what, if you ask me what is the call with a 3 or what, I don't know what either of those are. So then I'd have to kind of figure those out. So like, well, what is method 3 called with a 3? Okay. What is method 3 called with a 2? Can Mr. Zerla spell? Like, I don't know. So, all right. Well, we'd have to answer both of those questions. And it's going to look like this. Okay. I mean, it's going to be similar, right? But the difference is that 3 is fixed in there. But like right here, that's 3. That's made with a 2 now. That's made with a 1. Well, that's actually interesting. I know that. See, I know this value, believe it or not, right? It's a base case. If you call method 3 with a 1, you're going to get back a 2. So, okay, so I'm getting a little bit closer here. Now it's just, what is this piece here? I know the 3, I know the 2, but okay, well, let's go figure it out. So this one right here, if you called it with a 2, see this would be 2 minus 1, that'd be a 1. This would be 2 minus 2, that'd be a 0. Those are both base cases. So now I'm getting somewhere. Okay, this is a 3. I know this piece here is a 2. And I know this piece here is a 2. Those are both base cases. So now I know that this is 7. So up here, right, I was saying, what is it? I don't know. Now I know. Method 3 called with a 2 would return 7. That means that I could come up here now, and I don't have to leave this blank. Now I know. And so I've got the whole piece here. I've got the 3, the 7, and the 2. That makes 12. So now I know this value. And I didn't highlight it at the moment, but we actually know all these pieces now. So we've got our 3 here. Okay, we've got our 12 here. That's method 3 called with a 3. And remember, we answered this one a minute ago. This one's 7. So you've got 22 is what I'm predicting is the total. Now again, it's not printing all those numbers. This is a return method. We learned very early in the year, we got a return method. You can only make one return. This method has not returned yet. It has been waiting to resolve itself. It kept opening up these different jobs. It was disrupting itself. It was getting distracted. And these method calls have waited in the stack area until their resolution was reached. Once it has been reached, then it can resolve the method call and back up to where it last left off. So at some point it was here, it was like it got distracted. It said, I don't know what to do. So it opened up a new method call, which opened up some other ones. But once those got resolved, it was actually able then to resolve what this particular method call was, and it put in a 7 there. And then all these pieces just start unwinding themselves. Okay. And it doesn't really matter when you're adding numbers, right? Does it matter what order you add them in? It's not that crucial. When we're looking at the timing of the prints in method 1, then the order made a lot more difference there. But you're talking about adding integers, you're going to get to the same spot. So what did we predict? I already forgot. I think it was 22. Okay, pretty sure. All right, yeah. So 22 was the value that we saw there. Okay. All right. How does a recursive stack resolve itself? Well, see, this is kind of an interesting one here. So let's see. I'm going to turn this one off. We're going to make this first call with a 5. So we're going to make a call to method 4 with a 5. That's not a base case. The base case is a 2. So ultimately, when we call method 4, we'd like to see a 2 in there. Well, we didn't get a 2. So we end up in the else. Okay. And that means that I'm going to print a $sign. Okay. Then I'm going to call method 4 again, and I'm going to call it with a 4. Then I'm going to print a $sign. But here's the catch. Remember, not only am I going to do these things, I'm going to do them in a very strict order, the order that they were presented in. So first is the $sign print, then is the method 4, okay, call, and then is the print hashtag. But right here, I got disrupted. I got distracted. Okay. So, I think the example I gave in class was you're doing your dishes. Your mom told you to do the dishes. You're doing the dishes. Your dad comes home and says, take out the garbage. What do? Do you finish doing the dishes or do you stop what you're doing and take the garbage out? I don't know. It depends how things work in your house, right? But how mad your dad is. So if you stop and you take out the garbage, then when you come back, you'll finish doing the dishes. That's kind of the example of this being disrupted here. So we've printed the $sign. We still have to print the hashtag, but we're going to hold off on that because we're going to start some new chore right now. And the new chore that we're going to start is we're going to make a new method call. This time we're going to make a method call with originally a value of 4, which means that later when we make a recursive call, it's going to be made with a 3. Remember, ultimately, I'm looking to make a method call with a 2 because I've identified that as my base case. So this method call that has the 3 in it does make that method call to the 2. Now, the reason that's so interesting is that's a pretty easy one to resolve. So if you ask me, what is method 4 when called with a value of 2, I don't have 3 jobs to do. Since the if statement is finally true, there's really only one job to do, and it's to print 2 stars. Okay, so let's go back to what's taken place so far. The very first thing that happened at the entire start of this sequence was that we printed a $sign. So don't forget that. Like before anything took place, we printed a $sign. But then we got distracted and we called method 4. Okay, so just like right here, we had to pause, right? Let me just write out pause. Okay, so then we jumped down to here, which actually invoked another print statement, and these weren't print lines. So we have $2 signs right now. But then again, we paused again. Like we said, well, now I got to do this new method call. It's like not only did you get distracted when you were doing the dishes to take the garbage out, but then when you got outside, your neighbor said, "Help me carry these groceries into the house." So then you took the groceries in. When you finish that, you come back, you take the rest of the garbage out. When you finish that, you go back and finish doing the dishes. Now you have three jobs going on. Okay, method 4 with a 3. Look at this. It printed another $sign. So we have $3 signs now. But again, we had to pause. Okay. We had to go do this 4th job. So I don't know, you're carrying in the groceries. What could happen next? I don't know. Help me hang up this picture or something. I don't know. Okay. All right. So now this is the interesting one. Now there's no more recursion. Okay. So this is the last task getting added to our list of things to do, right? We had 4 chores. This was the 4th chore, and it's the first one that we actually complete. Okay. And we print $2 or sorry, 2 asterisks. Once you do that, then that brings you back to here where we have that last pause made. And now you could print the hashtag that completes method 4 with a 3's call. Okay. At that point, you're saying, all right, I've finished this job. I've got 2 jobs done now. I was given 4. 2 of them are done. I can come back here and check it off my to-do list. Then I go to here, I print another hashtag. I got this one done. I come back here. I'm fine. Okay. Wow. The first job you gave me doing the dishes, I finally finished. Okay. Now I can print that final hashtag. And so I'm predicting we're going to see $, 2 asterisks, and then 3 hashtags. Okay. You could try printing A's. Like I said, imagine right here. What if, and I don't mean a literal character A. I'm talking about like the variable value A. What are we going to see? Well, we're going to see originally a 5. Not only are we going to see a 5 here, we're going to see a 5 here. Now, remember, that was the last thing that got printed. So right here and here, if I change these to 5s, I'm actually changing these 2 characters to 5s, the one on the ends, the first and the last. This was the very last thing that got resolved out of that stack. Again, that's like we were doing the dishes. We went off on all those side traps. We came back and we finally finished doing it. It was the last thing that we did. And so at that moment, A had been assigned 5 for the duration of that method call. The only reason you see a 4 here is because remember that was a 5 minus 1. Okay, that's where that 4 came from. That's the only reason you see a 4 there. There's no equal sign here. We're not reassigning the value of A. We're simply opening up a new stream, a new method call with a 4 in it. But there's no assignment operator there. So you're not changing the value of the variable at that moment. You're just making a brand new method call. Okay, so like right here, these would both be 4s. Okay, so these 4s would go here, the second and the second to last. All right, if I change these to 3s, okay, this would be a 3, and then this would be a 3 here. And you could do whatever you want with the asterisk. I mean, if you did put an A in there, it would print a 2. But we're going to see the 5, 4, 3 kind of coming in on the ends, okay? Let's see if we see that here. Yeah, 5, 4, 3, star, star, 3, 4, 5. So the first and the last value printed. Okay, and I got one more here. This is actually a pretty easy one. This is one that doesn't have an explicit base case. So this code is only going to run a new method call provided that x is less than 5. So it's going to print a 2, make a call, print a 3, make a call, print a 4, make a call. But it actually does quit. See, so eventually when x hits 5, it fails to make another recursive call. So, I mean, you might say, well, what's the base case? I guess the base case here is kind of implicit that if it's not less than 5, nothing happens. So the base case would just be to do nothing. So you won't always see like an explicitly stated base case. This setup wouldn't really work in a return method. Remember, in return methods, you always have to have a guaranteed return. So you wouldn't really see that there. This would be more particular to a void type setup.